Here are two right triangles. One is a 3, 4, 5 right triangle, and the other is a 6, 8, 10 right triangle. And these two triangles are similar. And the word similar in geometry actually has very specific meaning. In this case, what it means is that all three corresponding angles are congruent. So this is 90 and that's 90. This angle corresponds to that angle and they're congruent. And this angle corresponds to that angle and they are congruent. And also that the lengths of the sides are in proportion. So for example, this ratio 3 to 4 is equal to this ratio 6 to 8. And another example, this ratio 4 to 5 is equal to this ratio 8 to 10. So corresponding ratios are equal to each other. And let's see if we can quantify that more formally, focusing on the sides. And what I'm going to do is label this point A and this point F. And I want you to imagine yourself standing at those points, and we're going to do ratios of sides from those locations. So let's first do opposite leg over hypotenuse. And for angle A, that ratio is going to be the opposite leg, which is 4, divided by the hypotenuse, which is 5. So that ratio is 4/5. And then if you're standing at angle F, that ratio is, the opposite leg is 8, and the hypotenuse is 10. So that ratio is 8 over 10. And as you see, those two ratios are equal to each other. Let's take another pair of sides. Let's take this time the adjacent leg, and adjacent means next to, and then the hypotenuse. And again, from A's perspective, the adjacent leg is the leg that's next to the angle that we're at, so 3, and then the hypotenuse again is 5, so 3/5 is that ratio. And then on the other triangle, if you're standing at F, 6 is the adjacent leg, and then again the hypotenuse is 10, so 6 over 10. And then finally we can take the final two pairs of sides that we haven't used yet, and that is the opposite leg and the adjacent leg. So I'll write those down. Opposite leg divided by adjacent leg. Oops, I don't need the equal sign. And then if you're standing at A, that ratio is opposite over adjacent, 4 over 3. And if you're standing at F, that ratio is 8 over 6. Now these ratios are used often enough in mathematics that they've been given names. And the first one is named sine, the second one is named cosine, and the third one is named tangent. And you might think to yourself, how am I possibly going to remember that? Well, the next slide shows you how. The way to remember sine, cosine, and tangent is to memorize SOHCAHTOA. It's a 9-letter word, and it's an acronym. And the letters stand for sine, cosine, and tangent as follows. First, the sine of an angle is opposite over hypotenuse. That's SOH. Cosine is adjacent over hypotenuse. That's CAH. And then tangent is opposite over adjacent. So let's see how to use them on the triangle down below. In this triangle, we'll first stand at angle A, down here, and we'll do the three functions. The first one we'll do is sine, and sine is abbreviated SIN, and the sine at angle A is opposite leg, which is 5, over hypotenuse, which is 13. So 5/13. The cosine of A is adjacent, so the one next to, divided by the hypotenuse, so 12 over 13. And then last, the tangent of A is opposite over adjacent, so 5 over 12. Now, if you were standing at point B, things will be a little bit different, because what's opposite you now and what's adjacent to you now will switch. from B's perspective, 12 is opposite, 5 is adjacent, 13 is always the hypotenuse though. So we'll write down these for B. The sine of B is opposite over hypotenuse, 12/13. The cosine of B is adjacent over hypotenuse, that's 5/13. And then finally, the tangent of B is opposite over adjacent. So when you compare these two columns that we just wrote, there are a lot of similarities, but a few differences. Okay, let's use SOHCAHTOA to solve a few problems. I'm going to do 13, 15, and 17, and I'll leave 14, 16, and 18 for you to do on your own if you want some extra practice. Okay, on problem 13, we're standing at the 59-degree angle. We're looking for the opposite leg, and we know the hypotenuse. Opposite, hypotenuse, that sounds like sine. So our equation will be the sine of 59 degrees equals x over 17. And we'll multiply both sides by 17. And then when we type that into our calculator, the result is 14.6. So that's the length of x. Let's look at problem 15. If we're standing at the 27-degree angle, we are looking for the adjacent leg, and we know the hypotenuse. Adjacent, hypotenuse, that's cosine. So the cosine of 27 degrees equals x over 20. And we'll again bring the 20 over as a multiplier. And when we solve for x on our calculator, the result is 17.8. In problem 17, if we're standing at the 40-degree angle, we're looking at the opposite side is 20, and the adjacent side is x. So opposite, adjacent, we are doing tangent. So the tangent of 40 degrees equals 20 over x. And in this case, x is in the denominator, so we'll have to be creative in solving for x. And what I like to do is create a ratio on the left-hand side like we have on the right, and then cross multiply. And when we cross multiply, we get x times the tangent of 40 equals 20. And what that means, if we divide both sides by the tangent of 40, x equals 20 over the tangent of 40 degrees. And that answer is, on the calculator, about 23.8. We can also use SOHCAHTOA to find missing angles, and here's how to do it. In this triangle, if we're looking for this angle, we know that 39 is the leg opposite us, and 44 is the hypotenuse. Opposite, hypotenuse means use sine. So the sine of angle A, I'll call this angle A, is equal to 39 over 44. And to solve for A, we'll look for the inverse sine button on your calculator. And once you pull it out, we'll put in this ratio, 39 over 44. And when you do that on your calculator, you should get 62.4 degrees. And that's the measure of angle A. Let's try problem 21. If we're standing again at this angle, then we know the adjacent leg and the hypotenuse. Adjacent, hypotenuse means use cosine. So the cosine of the angle equals adjacent over hypotenuse. And we'll look for the inverse cosine button on our calculator and then put in that same ratio. And when we do that, I'll do it on my calculator, and the result I got was 48.2 degrees. There we go. And then finally we'll do problem 23. Here we're looking for this angle. We know what's opposite us. We know what's adjacent to us. Opposite, adjacent means use tangent. So the tangent of angle A, again I'll call this angle A, is equal to opposite over adjacent. So angle A is going to be the inverse tangent of 10 over 33. And when you solve on your calculator, the result is 16.9 degrees. And that's how you use SOHCAHTOA to find angles.